So the next section in our topic is about separating mixtures, and at the start of the video I went through those techniques, things like filtration, evaporation, crystallization, separating funnel, distillation, fractional distillation and chromatography, all things that you have met before. And a mixture, as just a reminder, is defined as two or more substances mixed together, but they are not chemically combined, and so that means they are quite easy to separate. And the method that we choose to separate a mixture will depend on its properties, and we'll see that throughout our different techniques. On page 7 here we have a number of definitions that you need to be familiar with and that we're going to be using when we talk about the different techniques, so it's important that you know what these words mean. So if you come across a word that is in bold or underlined and you're not sure what it means, refer back to this page just to make sure that you're clear on those definitions. Just to run you through a few of them. So soluble is a solid that does dissolve in water. Insoluble is one that does not dissolve in water. The next three are the ones that people more commonly get mixed up. So the solute is the solid that dissolves in a solvent. The solvent is the liquid in which a solute dissolves. And a solution is a mixture of the dissolved solute and solvent. Now that all sounds like another language, so let me demonstrate with an example down below. So let's say, for example, I had some salt, I had some water, and I mixed them together. The salt dissolves in the water and we get salty water. Well, how could we apply those three words to this situation? What is our solute? Well, our solute is the solid that dissolves in the solvent. So which is the solid in this situation? It's the salt. So this is our solute. The solvent is the liquid in which the solute dissolves. So what is the liquid in which our salt is dissolving? It's the water. So the water is our solvent. And the solution is the mixture of the dissolved solute and the solvent. So what do we get when we mix our salt and our water, which are our solute and our solvent? We get salty water, which is our solution. So that might help you learn those definitions. So solute is the solid that dissolves. The solvent is the liquid that does the dissolving, or what the liquid that the solid is being dissolved into. And the solution is the final mixture. The rest of the definitions will also meet with our separating techniques. Residue and filtrate will be important for filtration. So the residue is a solid that remains in the filter paper with filtration. Filtrate is the solution that passes through the filter paper during filtration. Miscible and immiscible will be important with our separating funnel and our two different types of distillation, simple distillation and fractional distillation. Then distillate will also be important for distillation, as will the next two words, evaporation and condensation. Will also meet those with distillation. Remember, evaporation is the change of state from a liquid to a gas that happens below the boiling point. So it's not boiling because it's a change of state from liquid to gas below the boiling point. So that's the difference between evaporation and boiling. So say, for example, evaporation of water can happen from, say, 80 degrees C. That would be evaporation of water because the boiling point of water is 100 degrees C. So any change of state from liquid to gas below the boiling point is called evaporation. Then condensation is the change of state from gas to a liquid. So it's, in other words, the reverse of evaporation. It's going from a gas back to a liquid. So make sure you're familiar with these terms, and if you come across them in your notes and you're not sure what they mean, refer back to page 7. So over in the next few pages we're going to look at the different methods of separating mixtures, and we tend to call these separation techniques. And as I've mentioned already, the method that we choose depends on the properties of the substances in the mixture. What we mean by that is, for example, we cannot use filtration to separate salty water. Why? Because the salt is dissolved in the water, and so therefore when we pour it through the filter funnel, the salt and the water will pass through the filter paper because the salt particles are already mixed with the water particles. So filtration works on the properties of the solid being insoluble. In other words, they're not dissolved in the solvent or the liquid. So the properties are really important, and that will help us determine the method that we choose. So what I'm going to do is run you through these separation techniques. I want to do that as quickly as possible because we have met these all in year 9, for example. But it's important that you know them. It's important that you can identify which separation technique we would use to separate a particular mixture, and we'll put that all together at the end. I have some practical videos of me doing this. Other videos I will refer to other YouTube videos which are really helpful, and those will be linked in your Google Classroom as well. So as I've already mentioned, filtration separates an insoluble solid from a liquid. So the solid must not be dissolved in the liquid. If the solid is dissolved in the liquid, then what will happen is it will all pass through the filter paper. So here's your apparatus for filtration, and it's really important that you know this apparatus. You need to be able to draw, and you need to be able to label it, and it does come across different topics. So for example, there was a past paper question asking you to draw the filtration apparatus for an acids, bases and salts topic question. It was something to do with red cabbage indicator, I think, and how basically you would get the indicator solution without the cabbage leaves, something along those lines. And you had to identify, okay, well, the cabbage is a solid that's not dissolved in the liquid, so we can separate this by filtration. So essentially, if you want to remove a solid that's sitting at the bottom of a liquid, then you use filtration, and you need to be able to draw this apparatus. So I'm going to, on the next slide, to show you how you would draw this, because you can look at that diagram, you can learn it, to recognise it, to look at, but drawing it is a different story. So what I would suggest is get a spare piece of paper, maybe in your blue book or something, and draw this along with me. So when you're drawing apparatus diagrams, it's really important to draw them in pencil and to use a ruler to make sure that they are nice and neat. So when drawing the apparatus for filtration, I would tend to start with a conical flask first. It's easier then to draw your filter funnel in that afterwards. So the conical flask is the piece of apparatus that will collect your solution that passes through the filter paper. So draw your conical flask. I would tend to draw the neck first. So maybe watch me draw it and then try it yourself. So then we would draw the body of the conical flask. You can draw that as a diagonal line going down to the left, slightly curved at the bottom, but don't worry if it's not. And you want it roughly symmetrical, so the two sides are going out at the same angle, and that will be easier to do with your ruler, so remember to use a ruler for this. Okay, so there's your conical flask. That's what's going to collect our solution. I would then tend to draw my filter funnel next. So I would draw that by drawing a straight diagonal line, making sure it touches the neck. And when it's just past the neck, then stop your line and draw a straight line down into the conical flask. So you can see the neck of the filter funnel is being supported by the conical flask. Then draw another straight line up, and that's almost your spout of the filter funnel, and then draw it back out. And if it doesn't quite meet the conical flask, you can just make that meet like that. So that is your filter funnel. Let's label this so we can keep a track. So we've got our conical flask. We always label an apparatus diagram. So each piece of apparatus must have a label on it. Yes, we kind of have a universal symbol for each piece of apparatus, but it must be labelled to show what each thing is. And then this is the filter funnel. So that is the filter funnel. Inside the filter funnel, we must have a piece of filter paper. And how I would tend to draw that is simply by doing a V inside your filter funnel. So if I just draw a straight line down and then back up again, that is your filter paper. So it almost looks like a bubble writing Y, but without the edges filled in, and it's important that it is open at the top, that you don't have it closed off at the top, because that means I've no space to pour my mixture in. So this is the filter paper. And that's your apparatus diagram done. There's only really 3 pieces of apparatus: your conical flask, your filter paper, and your filter funnel. But the other 2 things that are labelled in your other diagram are your residue and your filtrate. Again, those are 2 definitions that we've met already. But the residue is the solid that gets trapped in the filter paper. So this is just showing where these your solid would get trapped and where your liquid would pass through. So the general name for the solid that gets trapped in the filter paper is called the residue. And the general name for the liquid that passes through the filter paper is called the filtrate. So if, for example, you were separating a mixture of sand and water, your sand would be the residue and your water would be the filtrate. So your sand is the solid that's trapped in the filter paper, so it's called the residue, and the filtrate is the liquid that passes through, and so that in this case it would be the water in that mixture. So on the next slide I'm going to show you a video of me carrying out filtration. If you're still not confident with filtration after that, you can watch the free science lessons video on YouTube on filtration. So just make sure you're confident in drawing that apparatus diagram, and maybe take a blank piece of paper now and try and draw it without looking at that. Make sure you're confident in drawing it neatly in pencil with a ruler, and labelling it carefully. Okay, in this video I'm going to show you simple filtration, which you've used many times before. So for this we need a filter funnel, we need a piece of filter paper, and we need a conical flask. So in my beaker here I've got a mixture of sand and water, and sand is insoluble in water, so you can see it's just sitting here at the bottom. So if I wanted to separate sand and water, which is an example of a mixture of an insoluble solid and a solvent or a liquid, then I use filtration. So I'm going to fold my piece of filter paper here, fold it in half and then half again. And then I'm going to take one of the edges off to the side just to make a little cone with it almost, and pop it into my piece, or into my filter funnel. Okay, I'm going to put my filter funnel into my conical flask so the liquid that passes through will be collected, and it's a simple case of pouring my mixture through the filter paper. What you can see is happening is my water is passing through the filter paper, so the water molecules are small enough to pass through the filter paper, but the sand molecules are not, because they're solid, and they cannot pass through the filter paper. So filter paper has little tiny holes that allow liquids to pass through, but not solids. So my water is passing through, but my sand is not, and you can even see that by the fact that the liquid passing through is so clear, as opposed to this solution which looks, this mixture which looks very cloudy, because of the sand. So it's quite, can happen quite slowly, so we'll not wait for it to totally happen, but if I pour some of this away, what we will see is that in our filter paper, and there's still some water passing through now, but in our filter paper will be the sand will be trapped and our water will completely pass through. So just some general terms to be familiar with. Our water in this example would be what we refer to as the filtrate. The filtrate is any liquid that passes through the filter paper. That's the general name for it. And the sand will get trapped in the filter paper, and that's what we call the residue. That's the general name for the solid that gets trapped in the filter paper. So filtrate for the liquid that passes through, and residue for the solid that gets trapped in the filter paper. If we left this to eventually filter all through, we would be left with the sand in the filter paper and the water in the conical flask. The next separation technique we're going to look at is evaporation, and that is how we separate a solute from a solution. Let's do a quick recap of those definitions. What is a solute? It's the solid that dissolves in the solvent. And what's the solution? It's the mixture of the dissolved solute and the solvent, the liquid that it has dissolved in. So for example, we can use evaporation to get salt from salty water, because the salt is the solute and the salt solution is obviously the solution. Now the problem with this is that we lose the solvent, so we cannot use evaporation to collect the solute and the solvent. So the solvent will evaporate off, and that will leave the solute behind. So if you want to collect the solvent as well, you cannot use evaporation. So if you want to make a note of that, you can. Again, you need to be familiar with this apparatus. So I'm going to run you through that diagram now. But what you can see in just even from your apparatus diagram is that we heat the solution, and as we heat the solution, the solvent will have a lower boiling point, a much lower boiling point than the solute. And so when we heat it, the solvent will boil or evaporate off, and that will leave the solute behind, so that will leave the salt behind. So I'm going to take you through drawing this apparatus diagram, and then I am going to show you how this works in the lab. So again, make sure you use a pencil and a ruler with this, and again, perhaps practice drawing this along with me so that you're confident in doing this if you were asked to do so. So with evaporation, we're using heating apparatus, so you need a heat-proof mat at the bottom. Again, this is the first thing that should be drawn with a ruler. Okay, so that's your heat-proof mat. Again, make sure all pieces of apparatus are labelled. Next thing I would draw would be your tripod, and I would draw that again using a ruler by drawing a diagonal line up, just slightly diagonal, then a horizontal line across, and then a diagonal line down. So it's always 2D diagrams, so a tripod would obviously have 3 legs, but I don't want to draw a 3D diagram. It's always 2D diagrams, just like you've been doing since the very start of your science lessons back in year 8. So that is our tripod. What do we put on top of the tripod? We put our gauze to make sure our evaporating basin doesn't just fall through the gap in the tripod. We tend to draw a gauze by doing little X's. Sometimes you'll see them drawn as just straight lines across, but that's not the best diagram for a gauze. So do them as little X's, and again label them as gauze, which is G-A-U-Z-E. Next, we draw our evaporating basin, which is essentially just an open, shallow bowl. So it just looks like that. So it's not too deep as such, and it remains open at the top. So we label that evaporating basin. And that's where we pour our solution. So you can draw in the line of your solution if you wish. And that is your solution that you're trying to separate out your solute from. Remember, when we heat it, the solvent will evaporate off and we'll be left with our solute. And how do we do this? We heat this generally with a Bunsen burner. You don't need to draw a complicated diagram for a Bunsen burner. How we represent that is just by an upwards arrow going up towards your evaporating basin, and in capital letters write the word heat. So that's your apparatus for evaporation. You need to be confident in drawing and labelling that. So give yourself a little bit of practice in that. Now I'm going to show you a video on how we carry that out in the lab. And again, if you're still not confident in this, then watch the free science lessons video on evaporation. Okay, so the separating technique I'm going to show you now is called evaporation, and we use it to separate a soluble solid from its solution, or from the solvent that it's dissolved in. So what I have here is a solution of salty water. You can't actually see the salt in it because it has dissolved, and that shows us that a separation technique of filtration would not work because the salt is mixed with the water. So if we were to pour this through a filter, the salt particles would pass through as well, so it wouldn't separate my salt from my water. If you see some steam rising, that's just because I've used some boiling water to prepare this solution. So what I'm going to do is pour a little bit into an evaporating basin. I'm just going to pour a small amount so that we can see this happening. Okay, and I'm going to put it over a Bunsen burner on a tripod and a gauze. Set it on top of the gauze, and I'm going to light the Bunsen burner. Okay, so I'm going to keep my flame on this one about half open, half closed, just so that it's hot enough to heat my solution, but it's not the fully roaring flame. That's the one we use for solutions and liquids. So as I heat this, it'll take a minute to start heating up, but as I heat this, the water from the solution will start to evaporate, but the salt particles will be left behind. And that's because water has a boiling point of 100 degrees C. So when it reaches 100 degrees C, it will evaporate. It will turn into a gas and evaporate off. But the salt particles will have a much higher boiling point, even a much higher melting point. So they will not even melt, never mind evaporate off as well. So we'll leave this going for a little minute. So we can start to see the water evaporating now. The solution is bubbling, which means that we're forming a gas, and that's just simply the water evaporating and forming steam. So the water is starting to evaporate off, but it will be leaving the salt particles behind. If you can notice, look very carefully around the rim of the solution, you can start to see salt particles forming there. So here we have a time-lapse video of the rest of the solution being heated up and the water evaporating. So you can see the water evaporating here, and this is not real time, this is sped up, and you can see we're just left with the salt particles at the end. And here we have the final product, which is just our salt that we are left with. So evaporation can be used to separate out a solute from a mixture, from a solution. But the problem is that we lose the solvent. So obviously when we heat the mixture, the water is evaporating and it evaporates off into the air, into the atmosphere around it. So we can't collect the water as such. At the end, the only thing we have collected is the solute, which in this case are the salt particles. Before we move on to our next separating technique, let's look at how a combination of filtration and evaporation can be used to separate a mixture of sand and salt. So let's say we had a beaker, and inside the beaker was some salt, which I have shown in black dots here, and there is also some sand in that mixture too. So two solids within this mixture, but both very tiny particles. So it would take us a very, very long time to pick up each and every granule of salt and of sand and decide, is that salt, is that sand, and separate them out into two different beakers. What would be much quicker is to use a combination of filtration and evaporation. Now obviously we can't just pour it straight through the filter funnel, because both the salt and the sand would get caught in the filter paper as the residue, because they are both solids. So what I want you to do is have a think about what you could do to separate this mixture of salt and sand. So what I would like you to do is pause the video, have a read through the equipment you have, and see if you can come up with a method for separating this mixture of salt and sand. This is something you'll have done before in junior school, so cast your minds back, pause the video. If you want to, you can make a few rough notes at the bottom of this page or on a spare piece of paper, and then check the video to make sure that you've got the correct steps before writing them into your notes. Or you can just go straight ahead and write them into your notes here. So have a go at that now, see if you can plan a practical to separate a mixture of salt and sand. Okay, so let's have a look at your method and see if you've got all the correct steps. Again, if you haven't had a go at this, please pause the video and try it yourself before watching the video. So the first thing we need to do is place the mixture in a beaker and half fill it with warm water. What will that do? Well, that's going to dissolve the salt, but not the sand, because salt is soluble in water, but sand is insoluble in water. So if you want to add that as a side note, then you can. What will we do then? Well, just to ensure that all the salt dissolves, what we're going to do is stir it with a glass rod. You'll notice that on your equipment list. So we're going to stir with a glass rod, and that is to ensure that all the salt dissolves. What will we do then? Well, at that stage, when you're writing a method and you're not sure how do you get to the end, just always think, well, what do I have at this stage? Well, in your beaker, you're going to have your salty water because the salt has dissolved. So at this stage, you have salty water. You obviously don't need to draw this in to your method summary, but just if you're thinking at this point, oh, I don't know where to go next, think about, well, what do I have and how do I separate that? What do I have? How do I separate that? What do I have? How do I separate that? That's how you should go through your method and determine your steps. So start with a glass rod. We've got salty water because all of the salt is dissolved in the water that we added, and then we've got the sand at the bottom. So how do I separate that? Well, the sand hasn't dissolved, it's insoluble. And so what we can do is use our filtration to get the sand out, because the sand will get caught in the filter paper. So at this stage, we're going to filter the mixture. If you filter it into a conical flask, then that will be there to collect your solution. So again, I might ask myself, well, what do I have at this stage? So what do I need to do next? So excuse my shocking diagram, but let's think about what we would have after our filtration. So we've poured our mixture through the filter funnel, and the sand will have got caught in the filter paper, and our salty water will have passed through. So our salty water will have passed through. So we've separated our sand out now, so what we've got here is just simply sand. There shouldn't be any salt mixed with it as long as all of the salt dissolved in the water. So how then can we get our salt from our salty water? So again, if you have a think about what have I got now, then it's easier to see, well, where do you need to go next with your method? So at this stage I want to use evaporation to separate out my salt from my salty water, my solute from my solution. And so I need to pour my filtrate, which is my salty water, into an evaporating basin. Once it's in the evaporating basin, how then do I get the water out of my solution and to just be left with the salt? Well, obviously I'm going to heat it over a Bunsen burner until the water has evaporated. So that is your final step, heating the solution over a Bunsen burner until all the water is evaporated, and you should be left with just the salt in the evaporating basin after the water has all evaporated off. And if you were asked to do an apparatus diagram for your final step, that would be it there, obviously with pencil and a ruler, and each of your pieces of apparatus labelled. But you can see there you've got your heatproof mat, your tripod, your gauze, your evaporating basin. Inside the evaporating basin is your salty water that is heated with a Bunsen burner until all the water has evaporated off. So over in the next page you're asked a couple of questions. First of all, why can a combination of filtration and evaporation be used to separate a mixture of salt and sand? Well, think back to what was your first step. What did we do first of all? We added water to the mixture. And if both the salt and the sand had dissolved, this wouldn't have worked, because then when we poured it through the filter paper, both the salt particles and the sand particles would have passed through with the water if they were both dissolved. So this combination of filtration and evaporation works because salt is soluble in water and sand is insoluble in water. So it works on the principle that salt and sand have different properties. Salt is soluble and sand is insoluble. The next question asks why you need to use hot water, and it really should say at the end to add to the beaker containing sand and salt, not sand, salt and water. So you can score that out and just write salt and sand so that makes a little bit more sense. So why do you need to use hot water is the point of this question, and the point of using hot water and stirring is to ensure that all the salt dissolves, because if all of the salt doesn't dissolve, then there will still be salt particles mixed in with the sand when you filter it. So obviously salt will dissolve quicker if we use hot water instead of cold water, and stirring will also help it to all dissolve as well. So we don't want any salt particles to be left behind with the sand, and so we use hot water and stirring to get it all to dissolve. The next separating technique is crystallization, and it's very similar to evaporation. It's another method of separating a dissolved salt, in other words a solute, from a solvent. So it uses the same apparatus as evaporation, but it's just a slightly different method. And this is if we want crystals of the solute as opposed to just a solute in any form. So for example, with evaporation, if we use that to get salt from salty water, we would be left with very fine salt particles. But if we wanted bigger crystals, we would use crystallization. And you would have used this method in year 10 when you were making your copper sulfate crystals. So at the point where you had your blue solution of copper sulfate in a beaker, you would have poured this solution into an evaporating basin and heated it gently over a Bunsen burner until your solution was at about half volume. In other words, you had evaporated off about half of the solvent. So that's what crystallization is all about. Essentially, it's a slow version of evaporation. So if you look carefully at the method, you're heating the solution to boil off some of the solvent. So you're boiling off some of the solvent until it's about half volume. And you might want to make a note at the side that this is done in an evaporating basin. This creates what we call a saturated solution. A saturated solution is a solution in which no more solid can dissolve at that particular temperature. So if you think about dissolving sugar in a cup of tea, the saturated solution is when you've got the maximum amount of sugar, because you'll get to a point where you keep adding sugar, and some of it will sit at the bottom. No more can dissolve, and that's what you call a saturated solution if no more solute can dissolve in the solution. You then leave your saturated solution to cool, and as it cools, the solute becomes less soluble. So again, think about your cup of tea. Less sugar would dissolve in a cold cup of tea than in a hot cup of tea. So as a result then, your solute will crystallise out of solution, and then if you still have some solution left, you can filter off the remaining solution using your filtration, and that will leave you with the crystals in the filter paper. So in terms of leaving the saturated solution to cool, I would just add a note there that you can just leave the evaporating basin on a windowsill. So you're leaving the evaporating basin on a windowsill to cool slowly, and then the crystals will form. So essentially a summary of this method is to pour your solution into an evaporating basin, heat the solution to boil off some of the solvent until it's about half volume, and then leave the evaporating basin on a windowsill to cool and crystallise slowly. And then if you still have some solution left, you can filter that off using filtration. So I don't have video of me doing this, but again, you can watch that free science lesson video on crystallization to see that happening and see this being explained. But again, just remember, this is like evaporation. It's just basically a slow version of evaporation where we don't evaporate all of the solvent off at the time, and we evaporate off about half of it and then leave the rest to cool and crystallize. The next separating technique that we're going to look at is a separating funnel. And a separating funnel can be used to separate two immiscible liquids. Immiscible means liquids that do not mix. So for example, we could use this to separate oil and water, because oil and water do not mix. So basically what you do is you pour your mixture into your separating funnel, and you can see that the two layers separate out because they do not mix well together. So you can see in this example the oil is the top layer. That means that it is less dense than water. So the less dense layer is on the top and the more dense layer is on the bottom. You can see that you have got a tap here. And so essentially when you want to separate them, the two layers, you will need to remove the stopper. Otherwise nothing will flow because there's no air. No air can get through to replace the liquid that you have removed from the other end of the separating funnel. So you have to remove the stopper first, and then open the tap until the water has run off. So you can imagine the water will run off through the tap if it is open, and then you close the tap when you're just about to move on to the oil, the second layer. You close the tap and use a separate beaker to run off the top layer into. So this is something you may or may not have seen before, and just to show you this, I've got a video of me carrying this out in the lab. So with this separating technique, we're going to be separating a mixture of two immiscible liquids. That means two liquids that do not mix. So in this beaker I've got a mixture of oil and water. Oil is the top layer and water is the bottom layer. This is what we call a separating funnel. You may or may not have seen this before. And this allows us to separate two liquids that do not mix, two immiscible liquids. I'm just going to close the tap for now. So here we've got a tap, this is open and this is closed. So what I'm going to do is I'm going to pour my mixture of oil and water into my separating funnel. And with the tap closed, nothing will come through. Okay. What we need to do is put a lid on it first of all. And I'm just going to open my clamp for a second. And I'm just going to mix it gently. You should really mix it as thoroughly as possible. But just to allow the two layers to fully separate, to fully kind of mix with their own layer rather than the other one. But if we shake it too vigorously, the two layers can take a long time to separate, which we don't want to do in this video. Okay, so I'm going to clamp it back in. And before I separate, I need to take my lid back off, because if I keep my lid on and open the tap, nothing will happen, nothing will come out, because there's no air is able to get in and replace the liquid that has been left. You've essentially formed a type of vacuum. So you can see my two layers separating here. They're still separating. You can hopefully see they're still moving about. But we are going to separate them now. So in an ideal world, we leave them to fully separate, but for the sake of time, we will do this now. So you can see they're separating into their two layers, and ideally we'd wait until those are two distinct layers. Right now you can see they're still slightly mixed. So what I'm going to do is take a beaker, and I'm going to run my first layer off. The first layer to come off is going to be water. So I'll open my tap, and out comes the water, and you can see that it's water and no oil. Okay, the more open the tap is, obviously the faster the water will come out, but I want to slow it down at the point where my oil is coming close. So what I want to do here is stop it before the next layer, before the oil. You can see it's getting close. Okay. And what I've got here is pure water. You can see there, it is just simply water. I would set that off to the side. And what I want to do now is take a separate beaker and run the oil off into the next beaker, into a separate beaker, so that there's no water there. You can see it is slower to come out because oil is obviously thicker, more viscous than water. But what I could do is allow that then to run off into my separate beaker. So my separate layer, if that's oil or some other organic liquid essentially, I allow that to separate into a separate beaker. And what I'm then left with is a beaker of water and a beaker of oil. So separating funnels are used to separate a mixture of two immiscible liquids, two liquids that do not mix. So leaving that to fully flow through, and that would collect your oil there.